Good evening, everyone. I am Devan Sharma, and I am here to present our capstone project, which examines the impact of online and offline education on student performance and engagement. I am of Group 3. Now, education is evolving rapidly, and hybrid formats are now more than ever, more common than ever. Online education provides accessibility and flexibility, while offline education offers structure, motivation, and in-person interaction. Our project aimed to compare these two learning environments in terms of performance, engagement, preferences, and challenges. So, our problem statement: with the increasing shift towards the online education, there is also a need to understand how it compares to the traditional offline education in terms of student performance and engagement. Now we have some research questions, namely number one, how does a student performance differ from between online and offline education? What are the levels of student engagement in online education compared to offline education? Number three, what are the key factors that influence student preferences for either online or offline education, and what challenges do students face in both online and offline education modes, and how these challenges impact the performance and education. So the data source. To answer these questions, we created an online survey using Google Forms and distributed it to the St. Louis students by email and WhatsApp. So because of this, we collected nearly 501 complete responses covering demographic information, learning preferences, experiences, and performance perceptions. So the methodology: the data collection through Google's form survey. Then we proceeded with data cleaning and pre-processing. Then we did EDA on our data, and with the help of this, we did some visualization to compare the online versus offline. And after that, we did machine learning models to identify the patterns and trends. So the cleaning phase ensured that our data was reliable. We fixed inconsistency like standardizing labels in the field of study column, removed duplicates, and filtered out incomplete responses. So this step laid the foundation for our accurate analysis. So the key findings here: this was our dashboard. As you can see, we can see in the first one the education preferences, the domestic students and the foreign student, they all had the same opinion about choosing offline education more compared to online. And the next one, we can see the online challenges and poor internet connection and the lack of interaction with peers amongst the highest. And we can see the field of study. We can see that the information IT students had more, sorry, um, and third one, we can see that the IT students gave more responses, and that makes sense because most of our responses were from the IT department. And we also collected data from the University of Windsor, because and that could happen with some of my friends who go there. So, and in the last one, we can see the classroom engagement, and we can see the offline has more engagement in class compared to online. So that makes sense. These are the insights I just explained. um, Now moving on, we will start with the machine learning models. So feature analysis and encoding. To prepare our dataset for modeling, we encoded categorical data, ordinal encoding for engagement and satisfaction ratings. We did one hot encoding for fields like gender and education level, uh, binary encoding for yes/no questions such as, um, for example, did you take online courses last year? You know, Moving on. So the feature importance. The random forest classifier showed that job preparation mode was the strongest predictor of a student's preferred grade mode. Other important factors included online collaboration, material satisfaction, and offline support systems. Now, moving on to model development and evaluation. So we did the chi-square test to determine if there are statistically significant associations between the better grade mode variable and a series of another categorical variables. We did some null hypotheses and alternative hypotheses as well. We did null hypotheses, which stated that there is no association between the two categorical variables that were being tested, and the alternative hypotheses stated that there is an association between the two categorical variables. So our statistical analysis, the analysis confirmed that students were more engaged offline and that the engagement had a statistically significant impact on performance. We confidently rejected the null hypothesis in this case. So we also examined what influences student preferences. Chi-square test revealed that both online and offline factors significantly influence whether students prefer one mode over the other, with P was being 0.015 for online, and for offline the P was 7.81. So for the PyCaret model comparison, to evaluate the performance, we used PyCaret, which allowed us to compare models on metrics like accuracy, F1 score, and precision. This helped us identify the most reliable models for our dataset. The random forest classifier, this was both accurate and interpretable. It gave us strong predictions while also ranking the most influential variables affecting student outcomes. As you can see, the accuracy being 82%. The decision tree. So after the hyperparameter tuning with the grid search CV, the decision tree model was able to achieve 85% in accuracy in predicting which student perform better online or offline. So the model performance metrics. Our model showed strong and balanced results. Precision for offline was 91%, recall for online being 91%, and F1 score for both was 0.85. So these scores confirm the reliability of our predictions. We also did k-means clustering. We used unsupervised learning to group students into 3 clusters based on the responses, and each cluster showed unique patterns in learning, preferences, and challenges. And we also did principal component analysis that helped us reduce the number of dimensions and visualize how students were grouped. This made it easier to interpret the clustering results and detect clear patterns in the data. Uh, the XGBoost gave us better generalization and handled complex relationships in the data more efficiently. It further validated the conclusions drawn from other models. Its accuracy was 82%. And so this was our Azure pipeline. As you can see, I'll just scroll through this. Moving on. So the challenges and recommendations. So some of the challenges that we faced uh, includes missing responses in the survey, self-report bias, since students assess their own performance, generalizability across diverse student groups. We recommend combining the survey data with academic records in the future studies and expanding to a larger, more diverse population. So, all in all, uh, we can sum up in this way, like we can say that offline education continues to offer stronger engagement and academic results for most students. However, the online education's flexibility makes it ideal for independent learners and specific disciplines like IT. A hybrid approach that blends flexibility with face-to-face interaction may be the optimal path forward. Thank you all for listening to this presentation. Thank you.